All right, so continuing on with number 21, ask us to determine whether the lines are parallel, perpendicular, or neither. And so what I'm going to need to do is with this first equation here, which is x minus 7y equals negative 7, I'm going to put that into slope-intercept form so I can see what the slope is. So I'm going to take and move the x over to the other side, make it negative x, and then I'm going to divide everything by negative 7, being very careful with my signs. So I'm going to have y equals negative over negative is a positive 1/7 x plus 1. And so if we look at our slopes now, our slope for this one is 1/7, and our slope here is 4. So for them to be parallel, they have to be the exact same, so I know that's out. For them to be perpendicular, they need to be opposite signs and reciprocal of one another, so that's out. We then, if it's not parallel or not perpendicular, then the correct selection is that these two lines are neither parallel or perpendicular. They intersect at some degrees that is not 90 degrees. The next one here, we see x to the negative 1. We know we can't have a negative exponent, and so all we need to move is the negative exponent. So the negative 3 stays where it is, and the x to the negative 1 switches to the denominator and becomes x to the positive 1. Since the exponent is a positive 1, I no longer need to write it. Number 23. If I look at this, I have 3 to the 8th times 3 to the 7th, and that would be 3 to the 15th. And so if we can picture, 8 of these 3's and then 7 more of those 3's, there would be 15 of those. So 3 to the 15th. If we look at this one, this would tell us that we need to have m to the 6th 7 times. And so that'd be m to the 6th, and m to the 6th, and m to the 6th. There's 4 of them, there's 5 of them, there's 6 of them, there's 7 of them, and each one of these things would have 6 m's. And so our shortcut here is to just multiply and make that m to the 42nd. All right, if we look at this, they want us to look at the number 3 and determine what set of numbers it belongs to. So we should know that as soon as we see this, we know it's part of the real number system. So that is a yes. And then I determine, is it rational or irrational? It can only be one or the other. It can be written as a fraction, so it is rational. It is not irrational. It is an integer. It is a whole number, and it's actually a natural number. The next one asks us to solve the equation for y, which means we're putting it into slope-intercept form. So I have negative 24 equals negative x minus 6y. And so if I take and move the x over to the other side, it would become a positive x. And then if I divide everything by negative 6, this is going to be like a 1 here. So I'm going to have a negative 1/6x plus 4 is equal to y. And so it's y equals negative 1/6x plus 4. All right, looking at number 27, we're looking to be able to find the domain and range and determine whether or not it is a function. So when I look, remember that domain is x values, and I think left to right. So if I start by looking at the furthest point to the left, it has an arrow. The furthest point to the right has an arrow. And so that tells me there's no restrictions on the domain. It's from negative infinity to positive infinity. If I go and look at the range, remember for range we think y value and we think up and down. So my lowest point occurs right here at 3. My greatest points are here and here, and they both have arrows. And so that tells me that this goes between 3 and positive infinity. If I was asked to determine whether this is a function, yes, it is a function, because if you think about the vertical line test, a vertical line is only going to hit one point at any one time. So there would be no repeats in the domain, so yes, it is a function. All right, if we're looking at finding the domain, that means we're looking for the x values here. And so this is -4, 6, -2, -5. And so I'm going to take, and that's going to be -4, 6, -2, -5. And then the range is going to be the y values. And so that's going to be a -7, a 2, a -5, and a -2. We're asked to evaluate the function, so this is just a substitution problem. So I'm going to come over here and say that f of -3 would equal, I'm going to follow this, -2 times -3 minus 1. And so I'm going to do the arithmetic there, and that's going to be a positive 6 minus 1. And so that is going to give me a 5. F of 0 is going to equal to -2 times 0 minus 1, which means f of 0 will equal -1. F of 2 will equal -2 times 2 minus 1, which then f of 2 we're going to multiply and then subtract, and that's going to give me a -5. And then our last one here, if we have 11 x's, and then 9 x's, everything will cancel out except for these two. Or I could just subtract the 11 minus the 9 and say this is x squared.